Hello, gentlemen. Welcome to section 2.8, where we'll be talking about potential and kinetic energy in terms of the pole vault, but just in general, really. Now, energy comes in various forms. There are two particular forms that we'll be talking about today, and that's kinetic energy, abbreviated as KE, which is the energy associated with motion. So when an object's in motion, it has kinetic energy. We'll be talking about gravitational potential energy, which is abbreviated as GPE at times, and that's the energy associated with position. So at different positions, objects will have different energies. When forces act on an object, energy changes from one form to another form. But, what's really important to remember, the sum of the kinetic energy and potential energies remain constant. Again, when forces act on an object, energy can change from one form to the other, meaning it can go from kinetic to gravitational potential energy. It can transform. But the sum of the two remains constant. Now this lends us to a concept that is very important and that we've talked about before in the past. It's the law of conservation of energy. We talked about this when we talked about heat energy and energy in our bodies. We eat something and it turns into chemical energy, and that chemical energy allows us to produce work or hit something and have different energy changes. We'll talk more about that later. I don't want to give too much away for your question at the end of the lesson. Now, the law of conservation of energy says that energy cannot be created or destroyed. It can be transformed from one form to another. But the total amount of energy remains constant. So energy is changing form. You're not losing energy. You're not gaining energy. You're just transforming energy into different forms. Different types of energy. Now, an example of this would be throwing a ball in the air, or throwing any object in the air. We just finished our chapter on motion, projectile motion, or free fall. When an object is in the air, it has motion. We know that. I dropped. Now, my hand on this ball would thrust it up. That hand applies a force to get the ball to move. That's a force. That force creates some energy, or change in energy, really. Gravity also applies a force to slow the ball down when it gets to its apex, and then the force of gravity also speeds this ball back up as it comes back down towards your hand or down towards the ground. Key point is here. Whenever a force is applied to an object over a distance, we call that work. So when people say do work, that's what they mean. Do work. Work is done. Whenever work is done, the energy of an object changes. So when we apply a force to this ball, the energy is changing. As we apply a force to this ball in the upward direction, as the ball travels up, what happens is this. The ball gains motion. It goes, from rest in your hand, you apply a force to it, it gains motion. When it does, kinetic energy is the energy of motion. Kinetic energy increases. Potential energy, that's wrong. As you apply that force, kinetic energy increases momentarily, but as soon as that marker leaves your hand, gravity takes over. And we know gravity is a very powerful force here for us on this earth. And it will slow this ball down towards the apex. At the apex, we know that its velocity is 0 meters per second. In order to get to 0 meters per second, it must be slowed. So kinetic energy is actually decreasing as the ball goes up to its apex. And potential energy is increasing. It's growing in distance from where it originally started from. As it comes down, it gains velocity, thus its kinetic energy is increasing. It's the energy of motion. Its potential energy, or gravitational potential energy, either one you want to think of at this point in time, will be decreasing because your position is changing and you're going closer to where you originally started. We'll get more into this later on. Now, let's talk about what this means in terms of your investigation. So let's talk about the conservation of energy in a pole vault. But actually, stop at your investigation first. In your investigation, you bent a ruler. The ruler was resembling the pole in a pole vaulting act or activity. When you bent the ruler, work. We know what work is, we just learned about it. Work was done on the ruler. What this means is that energy was added to the ruler. What kind of energy was this? The ruler gained elastic potential energy. It's still potential energy, meaning it depends on the position, but it's elastic because that ruler acts like a spring. Elastic potential energy is the energy of a spring due to its compression or stretch. That ruler was compressed or stretched in a certain direction, and as you know, based on the properties of that ruler, it will go back to its original position. We call that elastic potential energy that it gained when it bent or compressed. Energy was transferred to the coin once the ruler was released. And you all saw that, and you all saw your pennies fly across the room. So when you release that ruler from its original position, here, you transfer energy to the coin. The coin gained kinetic energy. The coin went from rest into motion. It gained kinetic energy. But, as we just said with the ball, as the coin rose to the apex of its flight, the kinetic energy became gravitational potential energy. The more the coin rises, the less potential energy it has, the less kinetic energy it has, and the more potential energy it gains. The potential to come back down again. At its peak, at its apex, there is no kinetic energy because we know velocity is zero at that point. And we're assuming we're just throwing the ball straight up in the air. My picture before was kind of a parabolic shape. I just wanted to show you the different points of flight. But we're assuming we throw the ball straight up in the air. So at Y max, there is zero velocity. So we have all gravitational potential energy. It's all the energy it has is based on its position in the air. As it falls back down to the ground, we gain kinetic energy because we're gaining velocity, and we're losing potential energy because our position is going back to the original position that we started here in our hands. This start point is important. Even through all these changes in energy, all points during the rise and fall of this coin, the sum of kinetic energy and gravitational potential energy of the coin was constant. It did not change. We still abide by the conservation of energy. Now, I want you to ask yourself this. How does the law of conservation of energy apply to a pole vaulter? So apply these concepts that we learned from our investigation to this question here. Your whiteboard investigation today was about, the science or the physics behind pole vaulting. Now see if you can actually answer that using scientific language. Now, all that we've talked about, these different types of energy, are there equations that back them up? Absolutely. So is there an equation? And we know in physics, we do deal with equations frequently. So work is defined as large W, uppercase W, and it's equal to F times D. This is the force times your displacement. How far you're applying a force, or you're applying a force over a certain distance. Your elastic or spring potential energy is defined as, or abbreviated as EPE, and it is defined as half the spring constant. K is a constant that will be given to you. It's measured in Newton meters. Times x squared. X is the distance at which that spring has been compressed. The gravitational potential energy, known as GPE, is equal to the mass of the object you're talking about, times the g, the acceleration due to gravity, times h, which is the height at which that object is. So this marker has gravitational potential energy. It's above the ground. When I let it go, that gravitational potential energy is transferred or converted to kinetic energy. And lastly, we have kinetic energy. Kinetic energy, abbreviated as KE, is equal to 1/2 times the mass of your object, and mass is always measured in kilograms, times the velocity squared of your object. And that's how you would calculate the kinetic energy. Gentlemen, take notes on this. This is just a little bit about kinetic energy and potential energy. We'll deal more with this in the next sections. Enjoy.